Welcome. This video covers reading in Excel data, Sas data, and a couple other types of raw data formats. Let's start with Excel data. So an Excel data set is either a .xls file or a .xlsx file. And this is a really common way to store data. And you would think that maybe, hey, within the tidyverse, there would be a package to deal with that. And there is. However, it does not come built in with the packages that you read in when you run library tidyverse. Instead, you have to install this package separately and then read it in. But the readxl package does follow all the philosophies and is part of the tidyverse itself. But you do need to install this package separately. Remember, when you install a package, this is like buying the clothes, right? I don't need to do it every time that I open up R. I don't need to buy new clothes every time I start up R, but I do need to wear them. I need to load them in. I need to use that library command each time that I want to gain access to those functions in a new R session. All right, what function from readxl do we use to read in the data? It's the read_excel function. One issue with Excel data, though, is that you cannot read it from the web, so you do need to download it and then read it in from that path. And what we're going to do is we're going to start by reading in this censused.xlsx file. Okay, hopefully you've installed that package. At this point, we would do library to make sure that we then have access to all of the functions within there. And then we're just going to use the read_excel function. We're going to point it to that file. And so in this case, I've put this file in my working directory. So it already exists where R is looking, so I can just give it the path directly to that file, just the file name that is. And so I'm going to say read_excel, this Excel file. So it grabs that file and I'm going to save that object as an object called eddata. And again, this is part of the tidyverse, so it's reading this in as a tibble. And it gives me all of this lovely information about it. All right, what other functionality do we have with this readxl function? Well, of course, Excel spreadsheets have those pages going across the bottom, those sheets going across the bottom. And so you might not want to be reading in the data from the first sheet. And so there's this Excel sheets function, which will allow you to just look at what sheets are available to you. And just like with the read_excel function, we just need to give it the path to the file. So if this file exists in my working directory, I can just run Excel_sheets on that file. These are the sheets that are available in this file. And now if I want to read in a specific sheet, I would just add this sheet argument to read_excel, and I would be able to read in that sheet by the character string name associated with it. You can also use numbers as well, I believe. By default, this sheet is going to use the first sheet. Okay, that's Excel data. What about Sas data? A lot of people program in Sas, and when you program in Sas, you get out what's called a Sas file. So a Sas data set saves as a .sas 7bdat file. Okay, how do I read in one of those? Well, again, there's not a package that comes loaded in when you do library tidyverse that will read this in, but there is a package that is part of the tidyverse that will be able to do it, and that's the Haven package. So Haven will let you read in Sas data, SPSS data, lots of other kinds of statistical software. And so the function that we need for this is read_sas. Not too bad. We have this data set called smoke 2003.sas7bdat available on the web. We're going to go ahead and pull that in. Again, we need to install this package if we haven't done so already. And then each session that we want to gain access to this function, we'll do library Haven. And then we'll just point it to that file path. Since this data is coming from a different statistical software, it's going to already be in a very nice format, generally speaking. And so there's not a lot of options whenever you run read_sas. Basically point it at the file and you're going to get that information. You're going to get that data set read in correctly. Again, part of the tidyverse, so it does read this in as a tibble. All right, let's just briefly discuss a couple other sources and how you would possibly read that in. So Json Data is another really widely used type of raw data, and it stands for JavaScript object notation. And basically any kind of website that has data will have it in a JSON file. And JSON files can hold more than just a two-dimensional data set, so it can hold what you might refer to as hierarchical data. So certain variables could have subvariables and things like that. And so it's a lot harder to generally parse a JSON data set. It's not something that you can necessarily just say, here's 2 lines of code that will read in any JSON data. However, there is a package that was recently released that's part of the tidyverse to read in JSON data. The other package that I find works pretty well, I haven't really played around too much with tidyJSON, but JSON Lite as a package works pretty well too. But JSON Lite is not part of the tidyverse. tidyJSON is. All right, another really common type of data source is a database. And so a database just refers to a collection of data that's usually in the form of what we call tables. And these tables have some relation to them. So they have some keys that relate them. So this is an example chart of a very small database corresponding to baseball data. So this is the layman package. If you want, you can install that package and you'll gain access to all of these data sets, although they are not in the form of a database. They're just in the form of tables, or data frames actually. But there's a batting table. So when I say table, it's just another word for data frame essentially. So there's a batting table over here that has information about people and their at-bats. And you can see that there is a player ID, year ID, and stint variable. There's also the master table, and this has some of that same information. So notice that player ID is in both of these. So these are linking these two tables. There's also things like salaries, schools. There's also a pitching data set, etc. And so these tables are linked to one another through some of the variables that they share in common. So anyway, we would refer to something like this as a database, a bunch of data tables or a bunch of data frames that are all related to each other in some way. How do we connect to a database? Well, databases sort of come in a lot of different formats. So some of the most common ones are things like SQLite and MySQL. Those are two common forms of databases. And so what we can do is use the DBI package and then use the DB connect function from that package to connect to a database. Remember that this notation is just saying from the DBI package, use the DB connect function. So rather than reading in the entire DBI package, we're just going to pull this function from it. We're going to first specify which type of database backend we have. In this case, we have to have the appropriate R package, and then we need to use the function from that says that this is the kind of database. Then we can specify the URL to that database, the username, and password. And that will allow us to connect to a database. And we're actually saving this connection in something called con. So we have an R object that corresponds to this connection we've made to this database. And then what we can do is use the TBL function to reference a table in that database. So I can say table and then use the connection that we've just set up and then specify the name of the table that I want to grab. And from there, you can do queries to that database. So you can use SQL if you know SQL. We're going to learn dplyr, so we're going to learn some of this later. There's also dbplyr, database plyr. So there are lots of different ways you can then access tables within a database. You can join the tables, all that kind of fun stuff. And then usually the last step is to disconnect from the database and your connection to it. And there's a link here to a little vignette that goes through a lot of the different possibilities of what you can do with RStudio and databases. There is actually an area in that environments pane up there that also talks about database connections that you might have. All right, let's jump into R and just read in some Excel data and maybe connect to a database. All right, let's pop into RStudio. We're going to continue the same file. We're going to read in Excel data and connect to a database. Let's start with an Excel data set. We can't pull these from the web, so we're going to have it somewhere locally on our computer. And so I have this Excel data set here, chickens.xlsx, available in this folder. And so I can either set my working directory to there, I could use a relative path, or I can just copy the entire full path. I'm just going to do the entire full path. So I'm just going to highlight this up here, copy that, and then I know I just need to add /chickens.xlsx on the end. So I'm going to come over here. I need to read in the read Excel package, gain access to the read_Excel function. I'm going to put this thing in quotes. That's the path to the file. And then I'm going to do chickens, and we do need to be careful. It's a capital C. And then you might think, oh, okay, I'm done. I've given it the path to the file. This should work. But remember that a backslash is an escape character. And so if I actually want backslashes, I either need to put this to a / or use a double backslash. I'm going to go ahead and just use a double backslash. And now we should be able to read in this thing. Let's save this as chickens. So we're going to save the result of this function call in an object called chickens. All right, success. We now have a chickens thing up here. Let's just type it into the console. So this is a data set that has 3 variables. The first 2 are numeric, and the last one is a character variable. That seems correct. So that's good news. Looks like it read incorrectly. So again, that's all we have to do to read in basic Excel data. If we had multiple sheets, we could read in different sheets using the sheet command. Sorry, sheet input. And next up, let's go ahead and connect to a database. I'm going to use just what's called a local database. So I have an actual .db file that's going to be a database. And I have this, again, in this same folder. So I'm just going to be able to specify the path to that rather than using, say, a URL to connect to it. So I also have this diagram file that helps us understand what this database has in it. It has a bunch of different tables based around invoices and music. So there's some customers and they bought a bunch of music, and so there's a bunch of tables that are related around that idea. So how do we read this in? Well, first, this is an SQLite database. So that's the package that we need to read this in. So first things first, let's go ahead and make sure we have that package. There it is, SQLite. You will need to install that package if you haven't done so already. So I'll read that in. And then we need the DBI package. Generally speaking, I don't read in the whole DBI package. I'll just say, let's set up a connection. We'll do DBI. I want capital DBI, sorry. DBI, DB connect. And then what we need to do is give it the type of database first. So we read in our SQLite. So this is just going to be an SQLite database. So we're just going to use that function to say that's what we got. And we need to give it the path to the database. So again, here's where you would give it like a URL. But rather than give it a URL, I'm just going to give it this path to there. And then the data file itself is called chinook.db. And again, I either need to switch these to forward slashes or use two backslashes. I'm just going to go ahead and use 2 backslashes. And this one actually does not have a username or password required, so we don't need to give those arguments. Go ahead and run that. And now we have a connection. You can see up here in our objects, we have a connection to this database. There's a whole bunch of information about that connection. And so some of the names here, let's see. If we go back to that help file for it, there's some different tables like tracks, for instance. So I go in here, I can do TBL, my connection, and I should just be able to do tracks, I believe. There we go. And then we can see the tracks data there. So this is a way to connect to our database, pull some of the tables. We could pull 2 tables and join them together, but we haven't quite learned how to do that kind of thing yet. We'll see that when we get to the dplyr section. Now, you might also notice something funny here. This has question marks here. So this is doing a lazy evaluation, a lazy query. It's not actually pulling the data. It's just getting as much information as it needs for now. So you can run the collect function around this, and it will actually pull in the data and return it fully for you. So now it has, I have 3,503 observations or rows here. All right. So that's how we can connect to a local database. All right, so hopefully you're pretty excited. We've done a lot of really cool stuff, right? We can now read in lots of different kinds of data sets, raw data into R, so we're going to be able to do something with them. Read Excel for Excel data, Haven for Sas data, SPSS data, et cetera, et cetera. And then R has lots of functionality for any other kind of data set, raw data that you want to read in. And so here's our big recap. We're done with Module 1. What have we done? We've talked about the idea that there are common data objects in R. And we've gone through the idea of a vector, a data frame, and a list. We also know how to do basic base R subsetting of those data objects. And then beyond that, we are now talking about this whole ecosystem of the tidyverse, right? So a bunch of packages and functions that all have similar behavior and syntax. They're all meant to work together. They all have coherence with each other. And so it's going to be a nice framework to sort of just try to live in if you want to. One of the biggest issues with learning R is that there are thousands of ways to do the same thing. The tidyverse gives you a sort of way to say, well, there's a tidyverse way of doing it. Go down this path. And so that simplifies the learning of R quite substantially. And so next up, we're going to figure out how to actually go through data manipulations and summarizing data.